Afternoon, everyone, or good morning, I guess, depending on your time zone. My name's Jeff Albrecht, also here with John Healy. I am a geospatial developer data engineer at Arturo AI. John, would you like to introduce yourself?
Hi, everyone. I'm John.
Cool, and we're going to be talking about STAC FastAPI, which is an API layer that implements the STAC API spec. We have a quick little agenda. We're going to start with an intro and kind of walk through the history, some of the community around the project, and some of the design principles. And then John is going to take lead and show some coding examples that ideally by the end of the presentation, those of you who are listening should have a better understanding of how you could use this Python library, STAC FastAPI, to stand up a STAC compliant API to serve your STAC data. Let's get started. So STAC FastAPI, you can find it in the STAC Utils organization. And it's actually, those of you who are familiar with T-Tyler, which is an excellent project, it's actually very, very similar to T-Tyler. It's a FastAPI backed application that is sort of batteries included and pretty pluggable, such that a user can, in T-Tyler, you can implement a lot of your own tile server, tile fetching strategies, and STAC FastAPI is very similar. It's built on top of FastAPI, very much batteries included, but it's designed to stand up a STAC API. So you can find it in STAC Utils at STAC FastAPI. As far as history goes, this was originally written as an internal project at Arturo AI in January 2020. In September 2020, there was Chris through this cloud native geospatial sprint, which was a great time. And we took that time to open source the repo. At first, it was just living in Arturo's GitHub org. And then by March 2021, it was really Rob who had the idea to move it to STAC Utils, which is where you can find it currently. Been there since March 2021, so almost a year, which is a little crazy to think about. As far as community, since we open sourced it, there's been a ton of activity. Back in sort of end of last year, last summer, we did a major refactor to the repo, which you can see here. As the STAC spec was changing and getting to 1.0, we needed to refactor how some of the internals of the repo worked to be more sustainable as STAC hit 1.0. I have 25 contributors who've either opened issues, submitted code, but that doesn't even include all the people who've actually implemented the project. And ever since we did the refactor, we've had pretty slow and incremental development as STAC API spec evolves, as new extensions come out. The latest and greatest being the browsable and children extensions, which will be included in the next STAC FastAPI release. We've just sort of slowly been building in the background and making sure that the API is as up to date as possible with the API spec. As far as implementations, one of the main goals of STAC FastAPI is to be pretty backend agnostic, so you can really implement it with any data store. And just in the open source community, there's a handful of implementations that have already popped up. I'm sure I'm missing some. If there are any, I'm trying to get a better list of the implementations out there. So if you know of an implementation that's not on this page, please reach out to me in Gitter or probably Gitter or Twitter and let me know. Just trying to compile a better list of all the implementations that are out there. So we have a couple with Postgres. This was the first two backends that were created. One is SQL Alchemy and one is native SQL, which is pgstack. We also have a couple Elasticsearch implementations, one in-memory implementation, which is pretty cool, in Redis using a database called Tile38, which is a fun little geospatial in-memory database. And we have some NoSQL implementations with Mongo. As far as design principles, there are a couple of design principles that were sort of at the core of building STAC FastAPI when we first started. I wanted to spend some time talking through these because they're pretty important to understand. The first, and this is my favorite personally, my favorite part about STAC, is that STAC defines how you structure and model and serve your data, but not how to store it. a central idea to STAC FastAPI is sort of bring your own data store. We wanted to enforce explicit separation of concerns between the API layer, which actually implements the STAC API spec that adds the endpoints and does all the data validation on the data coming in and out, implements all the proper status code and error handling and stuff that's defined in the STAC API spec. But we wanted people to be able to kind of bring their own backend and make that process as simple as possible. Because at the end of the day, STAC is super use case driven. This is another super cool part about STAC is the core STAC spec is actually incredibly small. I really like the garden metaphor that Pete brought up earlier. I think that's a perfect metaphor to define STAC. And there's a couple different ways that you get different use cases in STAC. The first is the data. Everyone knows this spatiotemporal data comes in many different shapes and sizes. That is one of the problems that STAC was trying to solve, that every new type of data that came out had a different sort of API and portal, and it was impossible to do cool things like data fusion or even find data to begin with. And the way we've approached kind of solving that is building around STAC extensions. There's a number of STAC extensions that Matt brought up in the STAC extensions GitHub IO. There's so many I couldn't fit them on the slide, so there's just like 5 or 6 here. And these are community extensions that let you basically customize the way you are modeling your data based on what domain and what use case you're doing. Now, the other cool part about STAC extensions is there's nothing that's stopping you from writing your own. So at Arturo, personally, we use STAC quite a bit, and we have several internal STAC extensions that we use that we have defined as a way to extend STAC to meet our very specific use cases as a company. So STAC FastAPI is very much aligned around STAC extensions. This is the way that you, as a user of STAC FastAPI, if you want to build an API that serves data for a specific use case, you can use STAC extensions to extend the STAC spec, model your data in a way that's appropriate for your use case, and then be able to serve it through this API. The second dimension is API implementations. So there's a lot of considerations that go into actually building and maintaining like a microservice that's running an HTTP API. Some of this stuff is like middleware and logging. You might want to add cores if you're going to be doing this stuff in a front end. Authentication is something that's come up that's very use case driven. Most STAC implementations are open source, but I know that there are some imagery providers who implement STAC but want to lock down their endpoints using authentication. There's stuff like exception handling. What status code do I want to raise if the database throws a certain error? And even things like deployment strategy. A very common one is a lot of people will deploy services behind something like an Nginx load balancer, or they will have like a CNAME record that redirects and the actual domain name is different. And in dynamic APIs, you have the problem of link generation, and that can totally break all your links. So there's a lot of issues that you run into with deployment. The good part is that STAC FastAPI is just an extension of FastAPI. And you can do anything you can do in FastAPI, you can do in STAC FastAPI. And we're not going to touch on this too much in this demo because the FastAPI logs are really good. But if you want to do any of these use cases, from middleware logging to authentication to handling HTTP proxies, FastAPI has really good documentation on how you can actually implement that. And you're free to do as much, again, STAC FastAPI just extends FastAPI. You can do anything you can in a normal FastAPI or Starlet application. At the end of the day, the underlying design principle, the underlying goal that we're going for is we want to give developers the flexibility to implement STAC how they like, but without having to rebuild an API for every unique use case. Because, again, STAC is inherently use case driven. And there's going to be naturally a lot of variance in the way people store their data. I think the Django talk a couple of lightning talks ago was a great example of just different ways that you as an organization or you as a developer have to implement STAC, and it would be a huge pain if you had to build a one-off API every single time. So that's really the goal that STAC FastAPI is trying to achieve within the larger STAC utils ecosystem of tooling. In terms of the actual implementation, we're going to start diving into some code now. start with screenshots and we'll switch over to John, who's going to be demoing some of this stuff in action. If you go into the STAC FastAPI GitHub repo, you will see that it's actually a mono repo containing several individual packages. There's an API package, there's an extensions package, pgstack and SQL Alchemy. There's some test data, which is primarily used in CI/CD during the builds and for local development, and there's a types package. Decomposing these 5 sub-packages, each of them have a very distinct goal. This little diagram shows that. So the 3 main packages that most people will be working with if they want to implement their own STAC API from scratch is the API package, the types package, and the extensions package. So the API is where the FastAPI application is actually defined. This is what we call the API layer. This is where the API spec is enforced. So you're going to have a FastAPI application that implements all the endpoints for the various extensions, for the various conformance classes that the STAC API spec defines. There's no business logic happening in here. This API package is totally unaware of what code is actually injected into it. And then you have these 2 other packages called types and extensions, which basically just define interfaces, abstract base classes in Python for implementing different conformance classes defined by the STAC API spec. Types contains more of the core conformance classes, things like, core transactions extension are the 2 big ones that most people will want to implement. And STAC FAT in the extensions library, the extension subpackage defines things like query, sort, pagination, filtering, CQL, all the other kind of extensions that enhance the behavior or modify the behavior of existing endpoints. So for example, the search extension is a great one. Without the search extension, you can't query on any fields in like the properties key of your stack item. But once you add the search extension, you could do something like query for all the items that have a cloud cover of less than 15%. So STAC FastAPI types is really the core of STAC, of the STAC spec, and STAC FastAPI extensions are really the things that augment and supplement existing endpoints. Now, if you wanted to, let's pretend you wanted to stand up an API that implemented the transactions extension, which transaction extension in the STAC API spec, it gives you some RESTful CRUD endpoints where you can post to create, put to update, delete to delete, and you can add and remove items from your catalogs. You can create new catalogs, you can attach new items to those catalogs, you can delete catalogs. It's basically just RESTful CRUD endpoints on top of a data store. So you would start by first importing and implementing this base transactions client. You can see it's just an abstract base class and it implements like 6 or 7 methods. I'm just showing the first 2. One of them is create item and one of them is update item. So if we look at create item, you see it takes an item as an input, which is just a typed dictionary in Python, which is just a JSON blob with your stack data essentially. And at this point, depending on what your data store looks like, you would have to write some code, presumably, that creates an item. So if you're working with a Postgres, you're maybe doing some SQL queries. If your data store is S3, maybe you're sending HTTP requests to a bucket to interact with it. Maybe your data store is in memory, like in process, just like a list, like a Python list, and you're just appending items to that list. Any of that would work. Same for the update item method. And you can see in the doc strings that this create item method, once you implement it, it's called whenever you would actually hit the post collections / collection ID items endpoint, which is just the endpoint that's defined on the transactions client. That actually might be incorrect. I know there was an issue in STAC FastAPI to update and realign the transactions extensions with the spec. So this might be a little out of date with the current version of the spec, but that's totally fine because this is just an example. So let's pretend you finish implementing this base transactions client. You have all your methods written. If you're a good developer, you wrote test cases too, right? The next step, as shown up here, is now that you've implemented your client, you need to inject your dependency into this API layer. And what that looks like is there's just this STAC API class that's sitting in the API package. This is the class that most people are going to be interacting with. This is the class that encompasses the entire API layer. And there are a couple instance attributes that you can basically just drop your code into. And that's all you have to do to inject your custom business logic for whatever data store you're working with into the API. Once you instantiate this class, after you inject all your code, it creates this FastAPI application. And this application is going to contain all of your Stack endpoints that's calling the transactions client that you just wrote. All you have to do next is use your favorite Python, ASGI, WSGI server. Uvicorn works great, GUnicorn, there are a handful out there. And you can serve this FastAPI application. And then you have a Stack API that you can call. That's a very quick toy example of kind of how you can implement a client, inject it into this API layer, and then you have your Stack API ready to go. So one of the confusing parts about STAC FastAPI is there are these SQL Alchemy and PG-Stack packages. These are really just implementations of this kind of dependency injection pattern, where SQL Alchemy is a SQL Alchemy native implementation. It's using SQL Alchemy 1.3. It's not quite using the async endpoints yet. That's something that I'd love to get to, because FastAPI, of course, is an async, async application. In PG-Stack, which was written by David Bittner and a handful of other folks at DevSeed, is a SQL native implementation that will scale much better than SQL Alchemy. It'll scale much better because it's written natively in SQL and supports cool things like sharding and other things that let it handle much larger stack catalogs. Whereas the SQL Alchemy, I know a handful of people who are running in production and it works fine for smaller workloads, but it was really meant to be a toy example to get the API up and running. So keep in mind the difference there. API types and extensions are the three packages that you'll want to look at. SQL Alchemy and PG-Stack are great if you just want to deploy a Postgres-backed Stack API. But you mostly won't be touching any code in SQL Alchemy or PG-Stack if you want to implement your own Stack API. Cool. Now we'll switch over to John. You have a couple slides, John, yeah?
Yeah, I have a couple slides here. If you want to just
Yeah, I can just bump to let me know when you want to go next. You don't have any questions so far about STAC FastAPI, Stack in general?
It's probably best to check the getter. People that can't ask questions super easily.
Oh, right, yeah.
Can one import an existing stack catalog static files into PG-Stack FastAPI?
I know that's a really good question that I don't quite know the answer to. I know there's been work so there's the transaction extension, which is great for like one-off. I want to ingest an item. I know people who've tried to use the transaction extension to ingest hundreds of millions of records and it just doesn't quite work. So if you're working with Postgres, it's usually best to do some sort of copy statement or some sort of bulk insert and not go through the API to ingest. I do know that there is a bulk transactions extension. It's not defined in the spec, but it's implemented in STAC FastAPI, and it's slightly faster because it lets you send like 10 items at a time instead of one. But most of the people I know who are doing really big ingests of existing catalogs into any sort of data store are not going through a STAC API to do that. But it really depends on your use case and how much data you're talking about.
Cool. Bittner also said you could do that by creating an empty PG-Stack database and then using the loading utility PG-Stack to load your collections items from ND.json.
Oh, cool. So there is a load utility. That's awesome.
The PG-Stack utility uses PostgreSQL copy behind the scene, so it is suitable for larger lists of items.
Awesome. I wasn't far off with the copy statement. That's cool. That's already implemented.
Yeah, then Matt sounds in. Actually, the regular transaction extension supports batch as well as single items. Don't think anyone actually supports that though.
Yeah. Like I said, I think the STAC FastAPI implementation Phil created a couple issues on the repo saying this is out of date. And I believe we addressed some of that in PRs. I think John submitted a PR last week. Hopefully we can get around to the remainder of it to realign transactions with what's defined in the spec.
Awesome. Should we try to transfer to John? Looks like
John, you back?
Yeah, I'm back. Yeah, Jeff has a
Okay.
couple for me here, so we'll do those first.
Okay.
Yeah, we just added something to STAC FastAPI. I guess it's just for in SQL Alchemy right now, but it allows you to like post a feature collection to the create items route. You can like just create a single item, or you can post a feature collection, and then it calls the bulk transactions client. I haven't like tried the bulk transactions client in PGStack, but I know that like I put one in Mongo, and I was trying to load like 1 million items into Mongo, and I was just doing it like in a loop, like item by item. It was taking so long. I think it's because I have so many indexes as well in Mongo. But then the bulk transactions, it just like, it was like 20,000 times faster. So I don't know if it's PGStack. I don't know what the speed up for PGStack would be exactly, but yeah. So I'm going to talk about NoSQL backends, and just the theme of this talk, just adding your own backend to STAC FastAPI. I work at SparkGeo. I've been in industry for almost 2 years now. I was able to work for Arturo for a good chunk of last year, and I worked under Jeff. And Jeff kind of pushed me to contribute to STAC FastAPI, and he showed me and Brian Maddox how to build a custom backend for STAC FastAPI. Near the end of working at Arturo, I started on the Mongo and Elasticsearch backends. The idea there was just to build something more scalable. In school, I was always into distributed systems, and I've always wanted to, work on a huge design, like huge systems, like design architecture for backend systems. Phil Varner has contributed to STAC FastAPI Elasticsearch, and he was one of the key guys, or the key guy, I guess, I think, on the STAC API spec. So he's done a lot of work on there. We released version 0.10 3 weeks ago, and it's definitely the most developed NoSQL backend that I've worked on. Like this demo I'm doing is based on Mongo, just because Mongo is a lot easier to look at as far as just to see how like items are added to the database and stuff like that. But if you're going to be wanting to try out a NoSQL backend on your system, Elasticsearch I think would be the best. I'm also started working recently on like a tile 38 backend that Jeff talked about that. The idea there was like to have something for caching stack assets, just so you could do like super fast things for like tiling and stuff like that. Okay, yeah, Jeff, you can go to the next slide. So yeah, just the basic concepts here. You're creating your own STAC FastAPI backend. You create a configuration file, of course, to like instantiate your database, create your indexes, tables if you need them. And then you create a STAC FastAPI instance. Like in the demo, you'll see that with app.py. And Jeff was just talking a little bit about like creating clients, creating like your core client, your like transactions client to do like CRUD routes and stuff like that. And then Jeff also showed like the base classes, a little bit of that, just to where you can write your database logic, just so you have the logic that's called when you hit your API routes. And those are the basic concepts. And yeah, so I'll just present. I'm going to present my whole screen if I can. So I'll just, yeah, I'm going to go through this quickly. I'll just kind of talk about like what I would do now to create a backend, like after going through a few iterations of doing this type of thing. Like I'm working in Docker, so I have Docker file, Docker compose, MongoDB is set up, Mongo Express, that's just to see Mongo on a web page, is like nothing important. And then, config.py, I was talking about like instantiating your database and just like creating a Mongo client right here. And then these are my indexes in Mongo, creating like a geometry index for the GeoJSON stuff. And then we have core and transactions. App.py, which I should start with. App.py is calling in my Mongo settings, getting all the extensions I might need right here. See, it's calling all this stuff from STAC FastAPI, the libraries. These are like the extensions Jeff was talking about. models. This is like instantiating your fast API, like apps, import STAC API. So here I'm just like creating the app right there. I'm calling in the extensions I need. Some of these extensions I'm not actually using in this demo, but I've called them anyway. It doesn't really matter if you have them in there, I don't think, unless it slows something down that I'm unaware of. So yeah, this is just running, this is creating the app. This is like, just like ready to inject code into the API routes that are imported from STAC FastAPI. Those libraries are imported in setup.py right here. It's just, yeah, you'll see the libraries right here. Like, I'm calling in like types, the API extensions. So like when I run Docker, it'll just like install my API for me, my app. And then these are the clients. Core is like get all collections you see here, get a single collection, get an item collection, like all items that belong to a collection. Get search, post search. So these are the, like Jeff showed the base classes, and these are called here in app.py. You'll see here I'm creating, my client is coming from core.py, like core CRUD client. So I'm just calling in those methods there. And then the transaction, the client transactions client is called in right here. And that's in transactions.py. So this is like the CRUD stuff, like create item, create collection. And yeah, I don't have I'm not going to show the bulk transactions extension. So yeah, this is just like the bare bones of what I would put together just to start to create your own backend. And here, this is just like the same version of the code, but I have a lot of the code that I might need commented out. I didn't want to like do a bunch of typing with this. I also have, I created like an error checks library. So I noticed there's a lot of like similar errors in STAC FastAPI that you have to check, like make sure a collection doesn't already exist, like make sure there's not an item conflict. There can only be like one item ID in any collection ID. So I just have these errors that I will bring in later. You can see them if you look at the STAC FastAPI Mongo repo. You can see that there's just like these are used a ton of times in STAC FastAPI in the STAC FastAPI Mongo, and that's just to like make sure that it's up to spec. Definitely like the most up to spec version that I've worked on is the Elasticsearch backend with Phil Varner. So, I mean, if you really want to see something that's current, I would look at that one. So, yeah, and I also have serializers, which is just like serializing items. And you'll understand why in a little bit. It's calling in links, all the different stack types, just giving us models to work with, so that like in Mongo, I can just like I can insert like a recipe into the collections, like the stack items collection in Mongo. I can just like insert a recipe. So, you know, I have these models here just to make sure that I'm like sticking to the data model with items and collections.
And all these serializers do, right, is convert from the way MongoDB is storing the stack data to the way we want to return it in the API.
Yeah, that's right.
So it's pretty specific to Mongo implementation.
Yeah, the serializer code I did end up copying from SQL Alchemy, like when I first started, because there's something similar there, because, you know, you're always like taking data from like SQL tables and then converting them to like JSON or whatever.
Yep. Yeah, and this is just because you often will store your stack data in a different format, and before you return it through the API, you want to kind of hydrate it back into fully qualified stack items that meet the spec.
Yeah. I know we looked at one option, was like using JSON in Postgres to just store the items and collections at one point. Yeah, just going back to the error checks, these are the STAC FastAPI errors that you can import through the types library. So yeah, I'm just using those all throughout. Like they just give you the right like response, like if it's a 404 or whatever. So I'm just like raising those like all throughout my little script here or whatever. So yeah, like the first thing I would definitely do now is just and I'll just go through it. Yeah, like, first of all, I'll just create a collection. So I'm just gonna uncomment this code. We're bringing in one of the error checks in the first line, just make sure that the collection doesn't already exist. And then this is the Mongo statement. It's like super simple. It actually looks a lot like SQL alchemy in a way, I think. Then I'm just inserting the collection, which is right here, that's being inputted like from the API route, stack types.collection. And then I'll save that. And then I'll also implement git collection, which is also, this is just like a super simple implementation. If you want to look at the Mongo repo and see like what this would really look like, suggest doing that. And then one thing that I forgot is Docker Compose up. I'm in Turkey and it's like 10:30 here right now, but I usually stay up late, so it's not really an excuse to like do a bad job or anything. But we've been in Turkey since last July, end of June, and yeah, it's been pretty cool. So yeah, okay, I have the Git collection route and the item collection route, or Git collection, create collection. So I have this Postman collection, I guess it's called as well. Create a new collection. You can see the body here of what I'm posting. So it says success.
Yeah, cool.
Yeah, and then I'll create another collection just because. Okay, now I'm going to get a collection. So there's my collection. You see right here that like Mongo creates its own ID, like an underscore ID, and that's something like that the serializer will take care of course later. But I mean, this is definitely one advantage to Mongo. It's just like stores this as a document. I can search on any of these fields. Like I don't have to convert something to SQL tables and like convert it back to JSON. So that's one nice thing about working with Nosql or Mongo at least. Yeah. And
one thing I want to point out here, John, if you scroll down to links, one of the challenges of implementing, so in Stack you have like static catalogs that are in S3 where links are either relative or absolute, and they're usually going to be just like a S3 URL, HTTP URL to whatever resource. The challenge with implementing a dynamic catalog through an API is the links have to be typically auto-generated. And so you can see down here that John's app is running on localhost 8081, and this application is returning a self link, a parent link, and they're all relative to the base URL that John's running on. That's because STAC FastAPI, it has a couple, John was showing you those links classes. It has a couple helper utilities that given like a base URL, and it auto-generates those dynamic links for you. That's a really important part of implementing a dynamic catalog, is getting those links to actually link to the things you want them to link to. And there's some helper functions and classes in STAC FastAPI that make it a little easier to do that.
Yeah, I don't think the links are they're not implemented yet, and that's something that is happening in the serializer as well. If we go to like the collection serializer, you can see here
that create links call. Yeah.
Collection links.
So given the ID of the collection in a base URL, it'll go and auto-generate all those links for you.
Yeah, so I have another example here. I can just comment out this like simple example, and this is like a slightly more complex example. And now here, like it's getting the base URL and it's passing that to the serializer right here, collection serializer. So this should actually give us the right links, because we're actually on localhost 8083 instead of 8081.
Oh, you are? Oh, that's a great example of why you have to do dynamic links.
No, it's still not, yeah, it's not working now.
Did you save?
Oh no, I didn't save.
Oh no, there's a problem with live demos.
Yeah, no, I just have to uncomment the error check. And the serializers.
Yeah, probably need both of those.
See, now I got rid of the ID for the Mongo stuff.
And the links are
Yes.
8083.
Yeah. Yeah, so that's good. Definitely like everything that works in this demo is like definitely a good step forward. Okay, so yeah, we got our collections, and then I'm just gonna roll along. We'll do the get item and the create item as well. Get item. You see here is what I'm doing, like JSON.loads, and then PyMongo has like a dumps function. It's pretty complicated. So once I put the serializers in here, I don't know, I'm not gonna get to that today, but once the item serializer is in this method, then I don't have to do like this JSON loads dumps things. It just like works fine. Create item. So we can see the item here, test item. I'll create like another test item. And then we'll get the
what
item.
What happens if you create an item with the same ID?
I don't have the error checks in right now.
Okay, so it'll just fail.
Yeah, no, it will just, I think it will just create another item because Mongo like creates its own ID for things, right?
Okay, that makes sense.
The Mongo just create a bunch of copies of the same item. But yeah, that's once I put the error checks in there and make sure like you shouldn't create an item before a collection is created, and then you should check the collection to make sure that there's not an item with that ID existing in that collection. So those are error checks I would have to implement down the road. So I created the item, get the item. So yeah, there it is. And then we'll go back to the code here. And something else I wanted to show is just like a post search.
So this is how you would do like spatiotemporal queries, more advanced queries beyond just get by ID.
Yeah, like you see here, I have the intersect filter. This is just like Mongo code. It's nothing really important, but it works pretty good. Like it works on anything GeoJSON. Like I'm not sure if it does like, I can't remember the name of one of the GeoJSON types that I'm not sure if it does, but yeah, it does all the basic ones like point, polygon, like the bounding box search I just convert to like a simple polygon, but there's probably like a better way to do it. Just make sure I have everything here. Return. And see here, I'm creating like an item collection, a feature collection. So all the results I get back will just be like a feature collection. This is just query code. I'm not actually going to demo this, but it's in this demo code as well. I have this, save this. I have this demo repo up as well. If anyone wants to look at the basic implementation, then they can kind of just check the Mongo implementation. So yeah, I'll do the point intersection. So type feature collection, we got some results back. Yeah, we don't have there's something called the context extension that I'm just going to quickly show in a few minutes, or a couple minutes as well. It can tell us like how many items we got back from our search. As you can see, like the coordinates here, the point is like, it's pretty obviously like inside this polygon. So if I change this, I should get no results back, hopefully. So yeah, no results back. Put this back. So yeah, there's a feature collection. I'm not serializing it yet, so I'm still getting the Mongo ID. I should get 3 items back, like 2, because we created like 2 test items with the same ID, and then like the other test item. So I have that here. Commented out this return statement. Save. So here you'll see that I'm just like, it's like just matched. I'm just getting like a count. Like with Mongo, it's just like SQL Alchemy. You just create like a search instance, and then you just like append like all these different like search parameters that you want. You just like add them all together, and then you can just do a search with everything. So yeah, I'm just getting a count here of everything that I have. There's some logic for the context object. You'll see right here, it's like if self extension is enabled, context extension. Just set, I have it enabled in app.py, so it's all good to go. Now, if I do the search,
and this is one of the cool parts of STAC FastAPI is you can write a backend that implements as many extensions as you want, and then when other people can when other people use that backend, they can decide what extensions they want to use. Maybe you want to include all of them. Maybe you just want to include context and query. So in any of these existing backends like pgstack or SQL Alchemy, if you want to use any of that, you can basically decide what extensions from the STAC API spec you want to use. Maybe you don't want to implement pagination. Maybe you do want to implement sorting. So you have a lot of flexibility in terms of how you can kind of construct your API and what behavior that API does.
Yeah, like in Mongo, I haven't done pagination. I think that's the only one. I'm not sure. I can't remember. It's been a while actually since I worked on that repo. But okay, I did the search again, and here's the context extension. It just adds like this extra like dictionary or whatever. So it's just telling us you have 3 items that match. Your limit is 10. It return 3, match 3. So you can have like, you could have a million matches, but you're only going to return 10 because your limit's at 10 basically. I'll just like quickly create a new item just so we can make sure that this is working or whatever. Yeah, so now we're getting 4 items back. So yeah, Mongo has like really, I know this isn't a talk about Mongo, but yeah, I like talking about Mongo, I guess, but it has good geospatial querying. We're looking at like creating a Dynamo fast API, and yeah, it's a little bit more complicated, but I think you can only do point intersection in Dynamo, but I'm not entirely sure. I mean, if anyone knows anything and likes to talk about Dynamo, maybe hit me up on Gitter or something. And I think that's all I was going to show. Yeah. Anything else you want to talk about, Jeff, or you want me to show, or like?
I think that was great. We have about 10 minutes left. We could open up to questions in Gitter, or we could give time back. There are no questions.
Yeah, sounds good.
Yeah, and last plug, if you are implementing I'm trying to do a better like survey of all the backends out there. So if you're implementing a backend, especially if it is open source, please reach out to me in Gitter and let me know. We're actually in the middle of doing a big documentation refactor on the project because that's one of the big things that's missing right now is good documentation. Trying to get it up to the level of like PyStack, that just documentation is incredible. And want to link to existing implementations and other backends. So if you're using this in any way and it wasn't on that initial slide, please reach out to me or John.
So I guess I have one question.
Yeah.
I did before, but yeah, like what do you see as the roadmap for the next like year or two? I think you mentioned.
The next, I can tell you the next release, and then it gets a little foggy. The next release is going to have implementation of browsable and children extensions, which really take STAC API to a whole nother level in terms of how giving people flexibility to organize their data in different kind of catalogs and subcatalogs. Nathan Zimmerman, who's going to be talking, I think later this afternoon, has been doing that really great work, and we're getting pretty close to merging that. There's a documentation update that is in progress, just going through and updating doc strings, auto-generated documentation. I want to roll some of the stuff we talked about today into like a Jupyter notebook that's there. And so really trying to build up the documentation and make it a little easier to use. And then I think, I can't tell you exactly what the roadmap is from there, but basically continuing to support backend implementations and making changes as needed for quality of life. Yeah, awesome. And of course, any updates to as the spec evolves, new extensions, things that become valuable, want to pull those in.
Awesome. Yeah, I'm curious. Do you know how the browsable stuff is implemented? Like, how do you
Yeah,
Okay.
Nathan, you should ask Nathan. But he basically implemented a whole DAG inside STAC FastAPI where you can write this file that I think it's a JSON file that describes the nesting of your catalogs, and then it can just dynamically like create the subcatalog paths. So a great example to think about is Landsat with row path. You might want to have, instead of just having /collection/Landsat8/items, you could have /Landsat/collection/row number/path number/items, and you can start to kind of break up your dynamic catalog in a way that previously you could only really do with static catalogs because the API spec just supported like collection to items relationship. And so there's and the cool part about that implementation is just like the rest of STAC FastAPI, it's just implemented as some interfaces. So if you don't like Nathan's implementation, you can totally go and roll your own and inject that into the API, just like you can do with any of the other functionality in the project.
Yeah, I am very happy that the browsable stuff made it into 1.0. I felt for like a year plus that I was like trying to voice this thing on people who were like, I don't know, I don't really want to do that. I was like, no, it's going to make it awesome. And I feel like,
yeah, it's super exciting. And I'm really excited to see how people use it. I think it'll be the first API implementation that supports it because it's not trivial to implement by any means. Adds a lot of complexity, but you can do some really cool grouping. I really like the interoperability between STAC FastAPI and T-Tyler, but you could you could use browsable and children extensions to basically dynamically group your items into layers that you can then serve through T-Tyler. There's a lot of really cool interoperability that comes with those two extensions.
Awesome. And Phil just dropped the browsable and children PR for FastAPI, so you can explore. I guess the other thing I'm curious about, just sort of generally, is like scalability. Like, how do people scale out STAC FastAPI?
Yeah. Well, there's really two components, right? There's the backend, which is really up to you, however you want to scale that out. The API itself it's pretty lightweight and quick. If you really want something that's super performant, so in STAC FastAPI, there's an async await, and there's a synchronous implementation. And you can basically choose which one you want to use. The asynchronous application will scale much better in terms of the API layer. It'll be able to handle much higher queries per second on lower amount of resources. But at the end of the day, the API layer is really just a wrapper around typically IO-bound SQL queries, HTTP requests interacting with the data store. So your application, assuming you're not blocked in the API layer and you can handle kind of the load that's coming from requests, typically all as well as your backend scales, as well as those queries that you're performing against the backend scale. So something like Postgres, it'll get pretty slow when you have hundreds of millions of records in your spatial index. But then you can do cool stuff with pgstack where you shard it out temporally and break up that spatial index into smaller entities, so it's faster to query.
Did I hear someone talk about BigQuery? Is there a BigQuery thoughts at all as a backend? Or does that not work?
I'm not super familiar with BigQuery.
Fair.
I'd like to think it could work. I mean, any data store you can do spatiotemporal queries into would really work. So if BigQuery supports that, then in theory, it could work.
I feel like somebody was talking about this recently. I think in general, the thing with BigQuery, I feel like stacks in between. BigQuery has trouble with tiling because it's just not fast enough. You're just not going to see.
The higher throughput.
Yeah, it's got a latency to it as it spins up, thousands of machines, to scale out because it's built for that. So I feel like Stack could be somewhere between where maybe you'd accept that second or two or three wait, but yeah, I think that's the kind of limitation where it kind of should be possible, but may not be the most amazing experience.
Yeah.
There's something I wanted to talk about that I totally forgot. I mean, it's not really that important, but I was reading about this API framework called Robin. There's being presented at GeoPython 2022. I don't know if anyone's heard of it. It's like a Rust. It's built on Rust. It's a Python API built on Rust. And yeah, I was like, I hacked out the app.py and STAC FastAPI Elasticsearch, and then I just like brought in Robin and just like created the routes I needed. And then I had like a STAC FastAPI, like not FastAPI API running. So I thought that was
you could. There's nothing stopping you from not using FastAPI. You could totally hack you could subclass the API layer and use Flask or Robin or any other of those ASGI or WSGI applications.
Yeah, and you still have like all the great stuff that you get with STAC FastAPI, but just running like a different.
Yeah.
Awesome. Well, that takes us about to the next session. But yeah, thanks so much, guys. It was awesome to see, and thanks for taking the time to prepare, and John for staying up late.
Yeah.
Is that what I asked you on this time slot? But you did flex.
Yeah, thanks for having us.
Yeah, of course.
Yeah, thank you very much.